Welcome to the conference. So I'm not going to take up much of your time, but we'll proceed with the next session that we have. So today, to begin the conference, we have with us Janikaram, who is a practicing architect, analyst, and advisor with a focus on emerging technologies. He provides strategic advisory to technology platform companies, startups, ISVs, and enterprises. Mr. Janikaram is here to talk about how Kubernetes is transforming into a universal control plane for orchestrating diverse workloads based on containers, virtual machines, the public cloud, and WASM. So let's put up great applause and welcome him onto the stage.
Great. A very good morning to all of you. It's my pleasure to be at KCD Mumbai. So first of all, I want to thank and congratulate all the organizers of this community. It's not easy to pull off an event of this scale, and I know what effort goes into it. So let's start by giving an applause to all the organizers. Sayam, Divya, and rest of the team, fantastic job. This is completely community driven, and that's one of the reasons why I want to be a part of this. I traveled from Hyderabad exclusively to be a part of this. So thanks for making it. So let me get started. But before that, let me ask you a question. How many of you use Kubernetes in production? Wow, that's okay. That's at least 30%. How many of you use Kubernetes on a day-to-day basis as a hobbyist, enthusiast, learner, developer? Okay, great. So I have been associated with Cloud Native and Kubernetes since 2014, when the very first open source version of Kubernetes was started to become available. And since then, I have seen the evolution of Kubernetes. So today I want to talk about how Kubernetes is becoming the universal control plane. Now this is a very interesting evolution, and this is going to touch upon the journey of Kubernetes rise. So next slide, please. So the essence of Kubernetes is about scheduling, and scheduling is a very, very important aspect of any orchestration, any management tool. For example, in the very early days of computing, the operating system was evolving, and it is still responsible for scheduling your code into one of the CPU cores. Though this happens magically, you don't have to worry about it, but there is a scheduler within the kernel responsible to efficiently place your code or the applications into one of the available cores of the CPU. Similarly, I started my career with .NET and J2E application servers, and at that time the application server was responsible for scheduling the enterprise Java beans, or in the context of Microsoft world, the common complex components were scheduled in an application server. Then we hit virtualization with vSphere and then EC2, and what we don't realize is there is a lot of scheduling magic that goes into scheduling your virtual machine. For example, when you go to AWS Management Console, choose AP South 1 and choose the AMI, the config, and push a button, there is a lot of magic that is going on behind the scenes, and there is a scheduler in action. Similarly, Hadoop, which we are familiar with, leverages quite a bit of scheduling. And even platform as a service, if you come from App Engine, Heroku, Cloud Foundry, that kind of a background, what you don't realize is there is a scheduler responsible for taking your code and efficiently placing that in one of the cells, if you are talking about Cloud Foundry. And Mesosphere, which has eventually been replaced by Kubernetes, also leveraged a scheduler called Cronus, which was responsible for placing containers or processes in one of the nodes. And then there is Kubernetes, where the deployment unit, the lowest common denominator, is a pod, and there is a scheduler that actually takes it and puts it onto one of the nodes. So this is how we have seen the evolution of schedulers, and this only becomes bigger and better and more complex as we go along. So going forward, next slide please. So going forward, the Kubernetes scheduler is going to be the most critical building block of many distributed systems that we are going to use. Why Kubernetes is becoming the universal scheduler, or even before we call it as universal control plane, because it's very difficult. It's wow. So the event is really happening with some fireworks there. So as long as my slides are on, I am on. So Kubernetes basically uses a very simple approach to scheduling pods. For example, there are labels and selectors, there are annotations responsible for figuring out where your pod needs to go. If you have ever deployed a pod that needs to be scheduled on a GPU specific node, all you got to do is annotate your node with an NVIDIA GPU count, how many GPUs are available on that node, and then you have to annotate your pod that says, hey, this pod needs these many number of GPUs, and automatically Kubernetes will basically position or schedule your pod to one of the nodes that is actually running the GPU instance. So that is how it all starts. And then it actually becomes more interesting with concepts like node affinity and pod affinity. In highly available scenarios, you don't want to put all your stateful set pods in the same node. It doesn't make sense, because if that node goes down, you automatically lose your stateful application. So you can actually create a stateful application or a highly distributed application, for example, Percona database server, and say this deployment has 3 pods, but no 2 pods can exist on the same node, and that is called the pod anti-affinity, where you are distributing them across available nodes. And this is again a very powerful concept, though it looks very simple with labels and annotations. Behind the scenes, there is a lot of complex scheduling algorithm that actually works to make this happen. And not only that, you can also extend the scheduler by creating a custom scheduler. That's one of the advantages of using Kubernetes. So custom scheduler is leveraged by, for example, a lot of storage platform providers, for example, OnDat or Portworx or Maya Data, where they need to make sure they are hyper converging the compute and storage. You want to basically make sure that your stateful pod and your in-memory cache are residing on the same node. You cannot put cache on one node and your database pod on another. So it doesn't make sense. Ideally, they should be on the same node so that you can take advantage of the in-memory cache before you hit the disk. So database vendors and storage providers are now creating custom schedulers to bring some kind of a hyper-converged infrastructure to Kubernetes. That is also possible with the power of custom scheduler. Next slide, please. So what I want to drive home is scheduling is key to modern infrastructure. From EC2, Azure VMs or GCE, which are basically VMs, to containers, to database instances, big data, IoT and edge devices, serverless and functions, even ERP instances like SAP and PeopleSoft, scheduling is there everywhere. I want to give you some examples. If you take edge devices, so Azure IoT is one of those examples that basically leverages containers to package your sensory ingestion and streaming analytics inside every edge device. Now, if you take a large skyscraper, a huge building, and you want to place an edge device in every floor, and every edge device runs half a dozen containers to ingest the data from sensors, how do you basically manage this? There is, again, the scheduling algorithm that comes in, where you are actually figuring out how to schedule your edge devices in the building, and within the edge devices, how are you placing containers so that you can effectively perform the ingestion, stream analytics, and everything to do with data pre-processing in one of those edge devices. So, this is becoming very, very important for modern infrastructure. And as we proceed further with LLMs, generative AI, scheduling LLMs effectively is going to be another big challenge. And I wouldn't be surprised if we actually see a new scheduler that optimizes placing and scheduling LLMs. Next slide, please. Next slide. So I don't want to touch upon this, but I just want to, I don't want to do a deep dive, but just give you a quick overview of extending Kubernetes scheduler and orchestration. So Kubernetes is built to be highly extensible. Do you know you can actually latch on to the core Kubernetes API server and you can become one of the API resources just like a pod, a deployment, or a namespace. So that is actually called as API server aggregation. So when you create a YAML file, you can say kind followed by one of the resources that is exposing an API alongside Kubernetes API, and that gets further with custom controllers that you can write and custom resource definitions you create. And then there is an operator. For example, some of the database vendors like DataStax, they are doing a phenomenal job of creating these operators and controllers that manage databases like pods. So you can actually say kubectl get MySQL, and you'll get to see MySQL instances. How does that happen? Well, it leverages all the extensibility features of Kubernetes, like custom resource definitions, custom resources, controllers, API extensions, and wrapping all of that into an operator and deploying that as a part of the control plane. So this is becoming a very, very powerful concept, putting Kubernetes at the front and center of orchestration and management. So again, this is slightly advanced concept, but this is to give you a glimpse of what is possible when it comes to extending Kubernetes. Next slide, please. So today, let's take a look at where is the code running, where are the applications running, right? If you visualize an enterprise footprint, right, there is a data center, and of course there are bare metal servers, but predominantly this data center is running a virtualization technology like vSphere or KVM. So that is one deployment target. For now, consider more of VMs and less of bare metal. Then of course, app modernization, move to containers and microservices. A lot of code is running inside containers. That is the second big bubble, or the second big silo. The third one, which is as big as virtual machines, is the managed cloud services. A lot of enterprises are investing in hybrid cloud and multi-cloud, where they are distributing their workloads across various public clouds. They are consuming services like RDS, Google Cloud SQL, Azure Database for SQL, a lot of cloud-based managed services, and these public clouds are responsible for running code and a variety of workloads. And then a part of the applications are also getting deployed as serverless and event-driven functions. So, this is the current landscape of where the code or the applications are running. Majority of that runs on-prem, bare metals plus VM, lot of containers and Kubernetes deployments, and a significant chunk of applications are running in managed cloud services, running in the public cloud, and then serverless like Lambda, Google Cloud Functions, Azure Functions, Cloud Run, and so on. Now, unfortunately, we don't have a remote control or a unified control plane to tackle all these deployments. When you are dealing with virtual machines, you have to use vCenter. If it is containers, no brainer, it's Kubernetes. If it is managed cloud services, they give you tools like Cloud Formation, Azure Bicep, or Google Cloud Deployment Manager, or more extensible Terraform, Ansible, and so on. But a completely different infrastructure as code and management plane choices. And if it is serverless, it's much more complex and fragmented. Every tool is different, everything is different. Now, the most interesting part is Kubernetes is going to assume the role of this universal orchestrator capable of managing the workloads and deployment environments running across all these environments, all these choices. Let me start with VMs. How many of you are familiar with KubeVirt? Okay, just handful. Okay, so KubeVirt is a very fascinating idea of converging virtual machines and pods. End of the day, a virtual machine or a container has a life cycle, and there is a layer managing that life cycle. Now, when it comes to containers, the kubelet talks to the container runtime interface, and that is going to manage the life cycle of a container. Now, what happens if we are able to let Kubernetes talk to the KVM layer or the vSphere layer or the virtualization layer responsible for launching a VM, stopping a VM, starting a VM, and terminating a VM? and exposing that almost like a CRI interface, and then building infrastructure within Kubernetes like an operator, like a CRD and a custom resource that gives you the chance to say kubectl get virtual machines, right? And in the same namespace, the ability to run a virtual machine and a pod opens up a lot of opportunities for enterprises that are dealing with legacy code and modernized applications, right? So that is exactly what KubeVirt is all about. So KubeVirt brings virtual machines into the realm of Kubernetes and gives you an opportunity to treat virtual machines like a unified entity or a native Kubernetes resource like a pod, where you can use YAML files to define how your virtual machine is going to look like, and just like you define a pod spec, you will define the VM spec and use kubectl apply. And KubeVirt also comes with its own command called virtctl, which is a layer above, which will give you an independent access to the virtual machines. But a combination of this leads us to many interesting opportunities. To call out some of the industry examples, KubeVirt is the largest open source project. Red Hat is contributing to it, and many other players are a part of this ecosystem. And then a few years ago, after VMware acquired a company called Heptio, and Acquis hired two of the Kubernetes creators, Joe Beda and Craig McLuckie, they infused Kubernetes APIs into vSphere through Project Pacific. And today, in the current version of vSphere 8, you can treat vSphere as a control plane both for VMs and Kubernetes. It exposes both the APIs. That is another example. And Google Cloud Anthos has virtual machine management built into it. If you are deploying Anthos bare metal or Anthos on-prem, you can actually integrate Anthos with virtual machines. And another company called Platform9 that pivoted from OpenStack to Kubernetes is also doing a lot of work in converging virtual machines with Kubernetes pods. So these are some of the examples. Then the second major thing that I was talking about is the cloud services. Now, as I mentioned, the automation of cloud services is extremely fragmented. You have to use Terraform, you have to use CloudFormation or Ansible or Spaghetti shell scripts to automate. Now, wouldn't it be cool if you are able to open a YAML file and say, kind Amazon RDS type M2 large, and then you define certain specs about your RDS instance, and then you say kubectl apply. So Kubernetes already has access to your IAM credentials in the form of secrets and config maps, and this single kubectl apply command results in the creation of an RDS instance. And it throws the credentials that you need, which you can wire to your application, a stateless application, to form a dynamic elastic application with RDS being the stateful backend. That's exactly what Crossplane is all about. So Crossplane is a Kubernetes native infrastructure as code or config as code company that is building bridges between cloud native world and the managed cloud services world. How many of you are familiar with Crossplane? Okay, just again, a handful of you. But if you haven't checked out, you should take a look at Crossplane. If you have an account with AWS or Azure or GCP and have a Minikube running on your local machine, it takes 5 minutes for you to use kubectl to control your cloud. How cool is that? That is the power of Crossplane. So Crossplane is the bridge between Kubernetes and the public cloud. Now, what does this really mean? It is turning Kubernetes into an orchestrator or a control plane for non-cloud native workloads, which are managed services of the cloud. Next slide, please. And some of the examples, Crossplane is definitely the early mover and getting a lot of mind share, but CO, one of the sponsors and Siam's company, has invested in an open source project called Open Control Plane, OpenCP. That is another example. And not only that, realizing the power of Kubernetes as the control plane, cloud providers have started to build native operators and controllers. For example, AWS has something called ACK, which is AWS controller for Kubernetes. So again, you have a Minikube, you do a kubectl apply, with all the operators and the CRD definitions of ACK, and you can use kubectl to control the entire AWS control plane. One minikube orchestrating AWS cloud. Same thing with Azure Service Operators or ASOs. One YAML file, and after that you never have to deal with Azure CLI or Azure Bicep or Cloud, the Terraform equivalent or Azure Bicep. You can use minikube to manage Azure resources. Kubernetes config connector or GCP KCC is another such tool that gives you the capability to manage GCP resources from Kubernetes and kubectl. Now these are just examples of what you can do with Kubernetes and these controllers connecting you to the public cloud world. Next slide please. Now finally, I mentioned about serverless and functions where some code is executing. So serverless is all about event driven. You basically drop an object into an S3 bucket, it triggers an AWS Lambda function. That Lambda function calls a machine learning SageMaker endpoint, and it redacts every sensitive information in the PDF that you uploaded and writes the redacted non-sensitive PDF back into another S3 bucket, sends out an email that your PDF is ready for download. Now that workflow is event driven, and the trigger is basically dropping that PDF in one of the S3 buckets. Now how do you build that within Kubernetes? Well, there is a project called Keynote, and Keynote does this really well. It is built on top of the Istio service mesh, and it has two components. One is the Keynote serving and the other one is Keynote eventing. What you see on this slide is a subset of Keynote called Keynote eventing. But when you bring Keynote serving and Keynote eventing together, you can create serverless functions or environments on Kubernetes, because it has a concept called scale to zero. So what happens if you create a pod but you never invoke it? There is one instance of pod running all the time, consuming quite a few resources. Now what if that pod is moving into a warm state where it is the number of instances or the deployment replica count is 0? That is what Keynote does. And as soon as you use Keynote eventing to trigger a function, it goes back and pre-warms the pod, and it moves from scale to 0 to 1 or X, depending on how you configure, and once the job is done, it again scales back to 0. Now that is Keynote, a combination of serving and eventing. But that's not all. Next slide please. The community is actually building a variety of serverless capabilities on Kubernetes. Keynote is one of the most popular, OpenFaaS is another, and Fermion, who is one of the sponsors, and we have the founders here, so they are going to talk more about it, are also bringing the capability of serverless and event-driven into Kubernetes based on WebAssembly. So that is another example of how Kubernetes is again bringing itself into the environment and the universe of serverless, event-driven and functions world. Next slide. So what is the road ahead? Well, if you haven't invested in Kubernetes, and if you haven't looked at Kubernetes as the universal remote control, for me, Kubernetes is that remote control that can control your set-top box, your TV, your home theater, and everything. Just one remote control. That is what Kubernetes is turning into be. The universal remote control to manage VMs, to manage containers, to manage serverless, to manage the entire public cloud. And kubectl is turning into a Swiss Army knife with the extensions and what you can do. And combine this with the power of GitOps, you have an extremely powerful mechanism of managing your entire infrastructure in a declarative fashion and taking advantage of GitOps for lifecycle management. Imagine the ability of declaring your cloud resources, your functions, your VMs, your pods in a YAML files, and version control them in a Git repo, connect that to Flux or Argo CD, and you have an extremely efficient GitOps pipeline to orchestrate your entire environment. And all of that flows back to Kubernetes scheduler and Kubernetes control plane. Next slide, please. So the best way of visualizing and summarizing what I said is Kubernetes at the front and center of infrastructure, VMs, containers, cloud, WebAssembly. Whatever is the runtime, whatever is the deployment target, consider Kubernetes as your universal remote control and the universal control plane. That is the key takeaway from my session, and we have many exciting sessions lined up which will underscore and emphasize on the same thing. So have a great KCD Mumbai ahead. Thank you.
That was a very insightful session. Thank you, sir.